We all have been taught laws of reflection. If you have a mirror with point P and a ray of light strikes it, what do you think happens next? It obviously reflects back up. If we draw a normal perpendicular to it, we notice that the angle of incidence is equal to angle of reflection. But why is it so? At its core, light isn't a single line of balls. According to Huygens Principle, we can visualize it as a wavefront, carrying its disturbance forward spherically from its source, and its distance traveled is equal to product of its velocity and its time. Since Huygens could not explain the backward wave, Kirchhoff and Fresnel came up with their obscurity factor. This expression that you see over here describes the amplitude of the wavelet at any angle theta. At 0 degrees, cos theta becomes 1, meaning the wavelet is at its full strength, and it becomes 0 at 180 degree as we go backwards. So, when theta is equal to 0 degree, the wavelet is at its full strength. When it's 180 degree, it becomes 0. The backwards wave is mathematically 0. There's another factor in it. Fermat realized that light is very effective or efficient at traveling. So, let's say between 2 points A and B in a uniform Euclidean plane, light would take the shortest path or the path that takes the least amount of time, which here is a straight line, as you can see. Now, let's get back at our original case. We have a mirror over here. A ray of light from point A strikes the mirror at point P, and let's have 2 points B dash and B. B dash is positioned in such a way that by Fermat's principle, light would travel through it if there was no mirror, meaning there's a straight line between B dash and A, and the two triangles that form have a equal distance from a point D. That is, DB and DB dash are equal in length, and both of these triangles have right angle in common and a common side PD. Hence, by SS congruency, both of these triangles are congruent, and angle BPD and angle B dash PD are equal, and by vertically opposite angles, ACP is also equal to B dash PD. Now, what's next? Angle of incidence is equal to 90 degree minus angle APC, and same with angle of reflection but with angle BPD. After substituting step 3, we get angle of incidence is equal to 90 minus angle BPD. Hence, angle of incidence is equal to angle of reflection. Now, why does light take this path? According to Huygens' principle, when light strikes the mirror, a secondary semicircle wavelet is formed. Now, you may wonder, why isn't light everywhere? That's because of destructive interference. Each point on the semicircle formed is gonna be a sine wave of its own. And to understand destructive interference, we must understand what phase of a wave is. Phase of a wave is really just the state in which the wave is after a certain time t, or in our case delta t. So, in the path predicted by Fermat's principle and our geometric derivation, the difference in time among the waves is gonna be almost equal to 0, and hence difference in their phases will approximately be 0. Hence the waves add up and they form an even stronger wave. Now, what about in regions where Fermat's principle does not apply? Over there we are going to notice a 180-degree flip due to difference in time over there, and hence difference in their phases is also going to be equal to pi or 180 degrees. So the consecutive sum is going to be equal to 0, and hence we don't notice a net wave. So they really just cancel out each other and we don't see a wave over there. After all of this, we can finally understand what happens when a ray of light strikes our mirror. So when it strikes the mirror, a second semicircle wave forms. And by the process of destructive interference, all the waves which are not predicted by Fermat's principle of least time cancel out, and we finally get our reflected wave. And it satisfies a property, that is angle of incidence is equal to angle of reflection. So this property is really just a consequence of Fermat's principle of least time and Huygens principle. Thanks for watching this video. I really hope you enjoyed it and understood the concept clearly. Make sure to like, share and subscribe, and if you have any doubts, feel free to comment below.